Hello, hello, hello. It's Jono from Seneca, and today I'm doing another chemistry revision session, and we're going over rates of reaction, chemical reactions, and collisions. Really important topic, lots to cover, so let's crack on. To begin with, let's chat over what is the rate of a chemical reaction. Basically, the rate of a chemical reaction tells us how quickly reactants are converted into products. And in industry, this is super important. Because when we're making chemicals, we want to make sure we get the most products. But that doesn't necessarily mean faster rates are always better, and we'll talk about why a little bit later. So what does industry care about? They want to maximize the profit, maximize their profit. Like they're like Cardi B, all they care about is the money. They want to make the product as cheaply as possible, and they want to get as much as possible. They want the reactions to be fast as well, because that gives a better yield in a shorter amount of time. But there are a few drawbacks. It can be expensive to generate really fast reactions because you need really high temperatures, which are expensive. And that can also bring safety concerns if you have really, really high temperatures. So there's normally some kind of trade-off or compromise between speed, cost, and safety. Okay, so three key considerations when choosing reaction rates in industry: cost, safety, and speed. Okay. Fast reactions are often better because they produce more products in a given amount of time, but we do need to consider safety because high temperatures can be dangerous. One of the key things that you need to be able to do for this topic is plot reaction rates and calculate it using a graph. So what we normally do for this is we'll have the mass of the product on the y-axis and the time on the x-axis, okay? And what we have to do is we have to draw a tangent to the graph. And a tangent is just a straight line that touches the graph at a certain point, okay? And then we have to do a little bit of math. We calculate the rate of reaction by dividing the change in y by the change in x. So change in y divided by change in x. So once you draw the tangent, you make a little triangle that will then give you the change in y and change in x. So let's do an example. Say we drew a tangent to the graph. It's a straight line, it's at 90 degrees, and the change in y was 24, and the change in x was 4. What would the rate of the reaction be? It would be 24 divided by 4, which gives us 6. Okay, let's do another one. If we draw a tangent to the curve of a reaction, and the change in y is 14, and the change in x is 4, what's the rate? It's going to be 3.5. Okay, right, now we can't talk about rates without talking about collision theory. Collision theory is super important. Basically, what happens in a chemical reaction is the reactants collide, okay? And these collisions have to be successful for the reaction to occur. What are successful collisions? Basically, collisions that are above the activation energy. And activation energy is just the minimum amount of energy particles need to collide with to cause a chemical reaction. Okay? And what can we do to increase the rate of the reaction? We increase the amount of collisions. Okay? And there are lots of different factors that can do that. So that's quite a lot of information to take in. So let's do a quick review. What is the name of the theory that explains how reaction rates occur and why they occur at different rates? That is collision theory. Okay? Two key definitions: activation energy, minimum amount of energy with which particles must collide to cause a reaction. Collision theory is the theory that explains how chemical reactions occur and why they occur at different rates. And what was the key equation we went over? Rate of reaction is change in y over change in x, and we have to draw a tangent, which is a straight line at 90 degrees to the curve of a graph. Okay? And finally, what does collision theory say the minimum requirements are for a reaction? Two things: particles have to collide, and the energy of the particles must exceed the activation energy. So I hope that was a useful review of chemical reactions and collision theory. It can be a bit tricky, so maybe have a listen again, but I hope it was useful. Let me know what you think, and I will catch you on the next episode.